Good morning, dear students. From today, we'll start our last chapter of chemistry, that is your periodic classification of elements. Remember, 118 elements are known today. Out of 118 elements, 98 are naturally occurring or exist in nature, while the remaining are synthetic elements or man-made elements. These elements are prepared in laboratories. So what is the need of classification? Why periodic classification of elements is required? The reason is very simple. It is not possible for us to remember the properties of 118 elements. It becomes very difficult. But if we place the elements which exhibit similar properties into same group, then it becomes easy to remember the properties of the elements. Otherwise, if we want to remember the properties of 118 elements, it is not possible. It's very difficult. That's why the elements are placed in groups. That's why systematic classification of elements is required. In our syllabus, we have 4 systematic classification. Number 1 is your Dobonir-Streicht's. Number 2 is your Newton's law of octaves. Number 3 is your Mendeleev's periodic table, and number 4 is your modern periodic table. Mendeleev was the first who has arranged the elements in the form of periodic table. And modern periodic table which we are using now. So 3rd and 4th are important in this chapter. But still we have to learn the earlier also, that is Dobonir's law of triads and Newton's law of octaves. So what is Dobonir's triads? It's very simple. Dobonir has made a group of 3 elements. He have taken a group of 3 elements, and in this group the elements are placed according to their increasing atomic mass. And what you observed? The element or the atom which is present at the middle, its atomic mass is the average of the first element and the third element. As he has taken 3 elements together in a group, that's why it is also called Dobonir's law of triads. So here Dobonir tried to arrange the elements with similar properties into groups. He was the first one. He was the first one who has tried to arrange the elements in the form of groups. He identified some groups having 3 elements each. He has made a group of 3 elements. So he called these groups as Dobonir's triads. Dobonir also proposed a law known as Dobonir's law of triads. According to this law, when the elements are arranged in order of their increasing atomic mass, the atomic mass of the middle element was nearly equal to the arithmetic mean of the other 2, and its properties were lie between those of the other 2. For example, let us talk about lithium, sodium and potassium. It was the triad prepared by Dobbernius. It is the group of three elements: lithium, sodium and potassium, placed in the order of their increasing atomic mass. Lithium having atomic mass 6.9 U, unified mass. Sodium, its mass is 23 U, unified mass. And potassium, its atomic mass is 39 U, unified mass. Now, let us take element first and element number third. Atomic mass for first is 6.9. Atomic mass for third is 39. Now take the average. When you will take average for arithmetic mean, the value will be 22.95 U, which is equivalent to 23 U. And 23 U is the atomic mass of sodium. So he has prepared a group of three elements where the atomic mass of the middle elements is the arithmetic mean of first and third element. That's why this is called Dobbernius law of triads. But it was not applicable everywhere. It is having limitations. There were many groups which were not following this law. That's why it was a complete failure. Then comes the next one, Newland law of octaves. And what is the rule? When elements were arranged in a horizontal rows in order of their increasing relative masses, atomic masses, the properties of every eighth element were similar to the first one, just as the eighth note of musical scale. If you know about the musical scale, notes of musical scale, sa, re, ga, ma, pa, dha, ni, sha. So starting with first sa, second re, three ga, fourth ma, fifth pa, sixth dha, seventh ni and eighth sa. First and eighth are the same if we talk about the musical note. So similarly, if elements are arranged in horizontal rows in the order of their increasing atomic mass, then here we have lithium, then we have beryllium, we have boron, we have carbon, we have nitrogen, we have oxygen, we have fluorine, then we have sodium. So first, that is lithium, and the eighth one, that is sodium, will show similar properties. So that's how this rule came into existence. But Newland was not able to arrange all the elements in this manner. That's why it was also a failure. So in our next lecture, we will talk about Mendel's periodic table and modern periodic table. Thank you. Have a nice day.